Hey everyone, Linus here. Today we're diving into the fascinating world of CPUs, the brains behind our beloved computers. You know how we humans have brains that tell our bodies what to do? Well, CPUs are like tiny brains for computers, calling all the shots and making everything work. From the moment you hit that power button, to the second you shut down, the CPU is working tirelessly behind the scenes. It's a real workhorse, crunching numbers, processing information, and making sure everything runs smoothly. Without the CPU, your computer would just be a fancy-looking brick. Now, you might be thinking, Linus, this all sounds complicated. But trust me, it's not rocket surgery. Just like how we break down complex tech concepts on the channel, we're going to dissect the CPU piece by piece and make it easy peasy to understand. So buckle up and let's get our geek on. Okay, so how does this whole CPU thing actually work? Well, it all boils down to a simple three-step process: fetch, decode, execute. Think of it like the CPU's secret recipe for getting things done. First up, we have fetch. Imagine the CPU as a chef grabbing ingredients from the pantry. In this case, the pantry is the computer's memory, and the ingredients are the instructions from your programs. The CPU grabs these instructions one by one. Next, it's time to decode. Our chef needs to read the recipe and figure out what to do with the ingredients, right? That's exactly what the CPU does in this step. It decodes the instructions, breaking them down into simple commands it can understand. Finally, we have execute. This is where the magic happens. The CPU takes those decoded commands and, you guessed it, executes them. It's like our chef following the recipe perfectly, mixing, chopping, and cooking to create a delicious dish. And just like that, your computer performs the tasks you want. Now that we know the CPU's secret recipe, let's peek under the hood and see what makes this little chip so powerful. Don't worry, we're not going full-on tech teardown here. We'll keep it simple. First, we have the ALU, or Arithmetic Logic Unit. Sounds fancy, right? Well, it's basically the CPU's math whiz. It handles all the calculations like addition, subtraction, and even more complex stuff. Think of it as the CPU's very own calculator, crunching numbers at lightning speed. Next up is the control unit, the CPU's bossy friend. This unit is in charge of directing traffic, making sure everything runs smoothly. It fetches instructions, tells the ALU what to do, and keeps things organized. Imagine it as the conductor of an orchestra, making sure everyone's playing in sync. Now what about those registers? Think of them like tiny storage bins inside the CPU. They hold the data and instructions that the CPU is currently working on. It's like having the most important ingredients right there on the counter for quick access. And finally, we have the cache. This is like the CPU's secret stash of frequently used data. It's a small but super fast memory that helps the CPU work even faster by keeping important information close at hand. The CPUs we know and love today have come a long way from their humble beginnings. Back in the day, computers were massive, room-sized machines with CPUs made up of bulky vacuum tubes. Can you imagine needing a whole room just for your computer? But thanks to the incredible shrinking powers of technology, CPUs have gone through a mind-blowing transformation. We're talking miniaturization on an epic scale. Those clunky vacuum tubes were replaced with tiny transistors, and then those transistors got even smaller and more powerful. Today we have CPUs the size of your fingernail that can outperform those room-sized behemoths from the past. It's like having the power of 1,000 computers in the palm of your hand. And with each passing year, CPUs continue to get smaller, faster, and more efficient. The future of computing is looking mighty powerful, my friends.